Okay, so let's check your answers to letters B, C, and D and see how you guys did. In letter B, I have an x squared, an x, and an x as my leading x values for each of my groups. So in this case, I know I have 1, 2, 3, 4 leading x's, which gives me a degree of 4. To find the number of distinct zeros I have to take each of these groups and set them equal to 0 and solve. When I do that, x plus 2 equal to 0 gives me x is equal to negative 2. X plus 5 set equal to 0 gives me x is equal to negative 5. And x squared equal to 0 gives me 2 x's that are both 0. So in this case, letter B, how many number of distinct zeros do I have? I only have 3, since 2 of them are the exact same number. So in this case, I have 3 distinct zeros. Number of possible turning points is always my degree minus 1. So possible turning points is 4 minus 1, which is 3. And because these two are not equal, we only know this to be possible. This is possibly the number of turning points. It could be possible that we have less turning points than this, okay, and that's because these two are not equal. So we don't know that this is an exact number, so we're not confident enough to know that this is in fact the number of turning points unless we graph this function and see. So they're possible. And letter C, I have to set both of these equal to 0. When I do that, x plus 9 equal to 0 gives me x is equal to negative 9. X squared is equal minus 7 equal to 0. If I set them, split these guys up, I've got x squared equal to positive 7. So x is equal to plus or minus the square root of 7. So here I've got this 0, I've got this 0, or those zeros. My degree again is adding my leading exponents together. I have x squared here plus x gives me 3 x's, so I know my degree is 3. Because I had an x squared, I have a positive square root of 7 and a negative square root of 7. They both count as 2 separate answers. So I have 1, 2, and 3 distinct zeros. Since these two are equal, I know that my possible turning points are actually going to be an exact number. And I find that by taking my degree minus 1. So my degree minus 1 tells me I have exactly 2 turning points for that graph. In letter D, if I separate this, x minus 6 squared, the whole thing is squared, which means if I expand this, I actually have 2 groups of x minus 6, and I have to set each of those groups equal to 0. So x minus 6 and x minus 6, so I know I've got 2 values where x is equal to 6, and if I set x plus 8 equal to 0, I know I have an 8 is equal to negative, and x is equal to a negative 8. My degree, again, if I count them, remember if I expand this out, I have 1, 2, 3, 3 for my degree. I have 2 distinct zeros. These two are not equal. So my possible turning points stay just as possible. And I find that by taking my degree minus 1, so 3 minus 1 gives me 2. So I have possibly 2 turning points in this case, but it's not exact.